Hey everyone, we've made it to episode 10 of our Neet Chemistry series for 2025 and 2026. I'm your mentor, Sir Chongtham David, and today we're diving into a topic that seems simple but can easily trip you up. This is chapter, the name is called Solutions. Whether it's concentration terms, colligative properties, or Raoult's law, we are solving 45 smartly selected questions to help you gain full clarity. Just like the perfect solution depends on the right mix, your success depends on consistent effort and the right mindset. Here's a thought: the right concentration leads to the right results in chemistry and in life. So let's stay focused and keep pushing forward. Without further ado, let's dive into the questions which I've selected for you. The first question I'm sharing on the screen is, let us read together. How many grams of concentrated nitric acid solution should be used to prepare 250 ml of 2 molar nitric acid? The concentrated acid is 70% nitric acid. So the given options here, you have 90 gram nitric acid, 70 gram nitric acid, and 54 gram nitric acid in option C, and D, 45 gram nitric acid. Excuse me. So let us calculate the answer for this question. You know the relation between molarity, mole, and volume. By definition, molarity can be found out by weight of the solution, weight of the solute dissolved in 1 liter of the solution. So number of moles of the solute will be written as weight by molecular mass into 1000 if it is in ml, divided by volume in terms of ml. So, excuse me, you have 2, which is the given molarity. Weight, you know what is the molar mass of nitric acid? 63. 1000. And the volume of the solution in ml is given as 250. So you simplify this equation and the resultant will be weight. Can be easily found out. It gives 63 by 2 grams after calculation. Right. So weight of 70% acid would be, the 70% of nitric acid would be, you have to multiply this value 73 by 2. 70%. Sorry, I have to erase this. Okay. 70% of this nitric acid would give 100 divided by 70 into 31.5, because this is the value you have obtained by dividing 63 by 2. So the answer for this calculation would be approximately 45 gram. So it's evident from option D. Option D is the correct answer for question number 1. I hope the calculation is clear. Let us read question number 2. For a solution of two liquids A and B, it was proved that PS equals to XA P naught A minus P naught B plus P naught B. The resultant solution will be. Okay, let us read. The options: non-ideal, ideal, semi-ideal, none of this. So from the equation given by Raoult's law, you have pressure of the solution is mole fraction of A, P naught A minus P naught B plus, this is the relation from the Raoult's law by using Dalton's law, partial pressure. Then you open the bracket, gives P naught A mole fraction of A. You know, mole fraction is the fraction of the moles present in the solution. Multiply this with mole fraction of B plus partial pressure of the solid B in the pure state. Further, you can simplify this xb because the sum of the mole fraction in the solution is always equals to 1. So when you calculate mole fraction, if it is greater than 1, you know the answer would be wrong, right? So mole fraction should always be less than 1. So to find xb, you need to subtract from 1. And this xb, I think I have written here xb, should be xa. So this becomes xb plus p naught b. So from this given equation, you input the values and you can easily answer the question. So therefore, the pressure of the solution is now equals to pressure in pure state, mole fraction of A plus P naught B into mole fraction of B. So this is the condition for ideal solution. So B is the answer for question number 2. Let us read question number 3 and attempt this question together. This is based on ebullioscopy. If the elevation in boiling points of a solution of 10 gram of solute given molecular weight is 100 in 100 gram of water is delta TB, the ebullioscopic constant of water is. So from the relation, you have delta TB, which is the rise in boiling point temperature, equals Kb into weight of the solute multiplied 1000 with respect to 10 into 1000. Now, let us first write the formula, then later on let us give the value for this question. Molecular weight into weight of the solvent. This is the formula. From this, you calculate ebullioscopic constant. Now, Kb is equal to, this can be written as delta Tb 100 into 100 because you are given 100 gram of the solid, divide by 10 gram of the solid into weight of the solvent in kilograms, so 1000. Molecular weight is 100. Okay, so you can cancel this 100 and yeah, 10 gets cancelled. Kb equals to delta Tb. So C is the answer for question number 3. I hope it is understood and clear. Let us read question number 4. Which of the following solution will have the highest depression in freezing point? You have to find the Van Hoff factor for such type of question. This is very important. Multiple times such type of questions are asked in your exam. So find out which has the maximum value of particles. Urea is a non-electrolyte. It won't undergo. This is also out of the context. How many particles for aluminum chloride? 4. And for this potassium ferricyanide, it releases 5 particles. So in chemistry, particle means atoms, molecules, or ions. So 5 ions will be generated from this salt, complex salt, and hence it has the lowest freezing point. D would be the answer for question number 4. I hope this is understood. Let us read question number 5. It's quite lengthy. Okay, I hope it is visible to all of you. All right, question number 5 says two liquids X and Y form an ideal solution at 300 Kelvin. Vapor pressure of the solution containing 1 mole of X and 3 mole of Y is 550 millimeter mercury. At the same temperature, if 1 mole of Y is further added to the solution, vapor pressure of the solution increases by 10 millimeter mercury. Question asks you to find the vapor pressure of X and Y in their pure states, that is P naught X and P naught Y. So to find such type of question, you need to understand the Raoult's law and Dalton's law of partial vapor pressure. So according to that relationship which we have initially derived, the total vapor pressure in the solution is equal to the sum of the partial vapor pressure of the components present in the solution. This is Raoult's law. P naught B XB. Am I right? So from this equation, you can further derive you're given the total vapor pressure is 550. See, this is the vapor pressure of the solution. Okay, total means solution. So P naught A, you need to find this. Mole fraction is given 1 and 3. So 4, it would be 4 because 3 plus 1 would be 4. This is the mole fraction of A plus mole fraction of B. P naught B. This must be 3 moles, so 3 out of 4. Okay, so you have this equation. Construct this equation and find out the relation with a given equation. This gives rise to P naught A plus 3 P naught B. This would be approximately 500. Take the LCM, okay, and then keep this as equation number 1. And in the second case, how would you derive the relation? From the given equation, this parent equation P total, okay, we can write somewhere here for clarity. In the second case, let me write below, okay, if you can see. The total pressure or the pressure of the solution can now be written as, according to the condition, 1 by 5 plus P naught B into 4 by 5. Okay, so this is the relation so far. So can I name this as equation 2 after inputting the values here? P naught B, redo the rearrangement, P naught A plus, you can simplify this, P naught B equal to, now after taking the LCM, see you're given 560. The second condition is how much it is given here. The first one is 550. It increases by 10 times. So 550 plus 10 would be 560. I hope it's logically clear, right? So 560 and take the LCM from 5 and 5 gives, okay, multiplied by 5. This is the new equation that comes up. So you solve equation number 1 and 2 by subtracting and you will get the answer. So by solving 1 and 2, you get P naught B as 600 approximately, okay, and P naught A would be, do the solving part, P naught A, you can subtract equation number 1 and 2, okay, by any method, elimination or substitution method. So 400. So the answer would be 400 for X and 600 for Y. So answer would be option B. I hope it's clear, crystal clear. Let's move on to question number 6. Yes, 6.02 into 10 to the power 20 molecules of urea are present in 100 ml of its solution. The concentration of urea solution is. So how to find this molarity? It can be found out from this relation. 6 point, you're given how much molecule? 10 to the power 20 molecules. And since this is in ml, you need to multiply with 1000. Because by definition, the molarity is the number of moles of the solute dissolved per 1 liter of the solvent in, okay, 1 liter of the solvent, solution, sorry. So 6.02 into 10 to the power 23. This is the Avogadro's number. And given ml is 100. Do the calculation, you will get the answer. Approximately 0.1 molar is the concentration. So urea will have 0.01 concentration for this particular question. Option B would be the answer to question number 6. Excuse me. Let's read question number 7. To neutralize completely 20 ml of 0.1 aqueous solution of phosphorus acid, H3PO3, the value of 0.1 molar aqueous potassium hydroxide solution is. So you need to find this answer by using normality equation which you have learned. N1, N2, N1, V1 equals to N2, V2. Now, since this phosphorus acid H3PO3, this is called phosphorus acid, it is dibasic. Okay, that means there are replaceable hydroxide would be, sorry, replaceable H proton will be 2. So molarity will be n factor into its normality. This is the molarity part. So what? How will you write the value of normality? 20 volume given to you is zero point 0.1. Sorry, zero point 0.2. Okay, because you are going to multiply this with this 20 ml. 0. 0.2 liter. You have already converted this 20 ml into liter. And zero point 0.1 is the molar concentration. So you are required to find this V. So how to find? You need to cancel these terms. So V would be approximately 40 ml. So A would be the answer to question number 7. I hope it's clear and understood, right? So question number 8, let's read. Yes, two 1 liter flask A and B are connected to each other by a valve which is closed. Flask A has benzene in equilibrium with its vapor at 30 degrees Celsius. The flask B is evacuated and the valve is open. Which of the following is true if temperature is kept constant? A. Some of the benzene molecules would move to flask B from A. Vapor pressure will be half the initial value. The vapor pressure remains unchanged. Some more of the liquid in the benzene in flask A would evaporate. So by looking at the question, there will be no change in the vapor pressure, right? So the related option most appropriate would be C. C is the correct answer for question number 8. I hope it's understood. Let us see question number 9. Two aqueous solution S1 and S2 are separated by a semi-permeable membrane. Solution S1 has got a greater vapor pressure than solution S2. Water will be flowing from which direction in this case? So in case of osmosis, the flow of the solvent is from lower concentration to higher concentration through a semi-permeable membrane, right? So answer would be from S1 to S2. Remember the definition and you can easily come to the conclusion. Question number 10 is based on Henry's law. What does Henry's law states? The solubility of gas is directly proportional to the pressure applied. So Henry's law constant of oxygen is given 1.4 into 10 to the power minus 3 mole per liter per atmosphere at room temperature. How much of oxygen is dissolved in 100 ml at room temperature when the partial pressure of oxygen is 0.5 atmospheric pressure? So keep in mind, according to the Henry's law, the solubility of gas M can also be written Kp, where Kh or K is your Henry's constant. You are already given this value, right? So partial pressure of oxygen is given. To find this, PO2 can also be written as Henry's constant multiplied with the mole fraction of oxygen. So this oxygen mole fraction can be related as zero point 0.5 divided by 1.4 10 to the power minus 3. And you know, number of moles is related as weight by molar mass. Okay, and this n is given to you zero point 0.7 into 10 to the power minus 24, 10 to the power minus 4. This would be equals to m by 32. So from this equation, you can find this value of mass, which is equal to 22.4 into 10 to the power minus 4 grams, which is 2.24 milligram. Okay, so answer for this question would be option D. 2.24 milligram is answer to question number 10. I hope it's clear. Let's see question number 11. Which of the following liquid pairs shows a positive deviation from the Raoult's law? So a mixture of benzene and methanol, so positive deviation from the Raoult's law. For this, I'm going to give you important suggestion. You try to remember at least 10 examples each of ideal, non-ideal, and non-ideal categorized into two positive, negative deviations. So these are frequently asked questions in your NEET exam. Remember these points. Let us see question number 12. Dissolving 120 gram of urea in 1000 gram of water, it gave a solution of density 1.15 gram per ml. The molarity of the solution would be. Okay, prior to the options, let us first calculate the answer and find the options later on. Okay, so let us see the number of moles of urea. How would you find? Moles is related as weight by molecular mass. So what is the given weight? 120. Molecular mass of urea is 60. So answer would be 2. And total mass of the solution, total mass of the solution is 1000 plus, it would be 120 according to the question. So this becomes 1120. You need to add this too. Okay, it's very simple. Now to find the volume, the relation density is mass by volume. So volume is mass by density, which is equals to 1120 divided by density is 1.15 into 10 to the power 3. Then this gives rise to 112,115. Hope it's clear. So this would be in terms of liter because this is the value of volume we are finding. Now by definition, molarity is number of moles of the solid per volume of the solution in liters. So 115, this becomes 112 by definition. So calculate the answer, you will get values in terms of mole per liter. So this is the answer for question number 12. Let us see the options. 2.05, right? Remember that value? Yes, it's there. Right, bingo. See, is the answer to question number, yeah, it was 12, question number 12. Good. Then moving on to the next question, question number 13. Let us read. The vapor pressure of a solution of the liquids A and B are given, and it is found to be A and B is found to be 100 millimeter mercury. It shows that the solution exhibits. Now, from the calculation only, you can answer this question. How to calculate? You apply the Raoult's law of, yes, Raoult's law. According to Raoult's law, you have PT equals to P naught A, mole fraction plus P naught B, mole fraction of B. Now, input the values, you will get, it's given here 80, right? 80 multiplied with 0.4. This is a mole fraction of A. B would be 120. Mole fraction of B is zero point 0.6. So the answer is, uh, yeah, the answer would be 104 millimeter. Okay, so far you have the total pressure. And the observed total pressure is 100, which is less than 104. Hence, the solution was so negative deviation from Raoult's law. The answer is B, negative deviation from the ideal gas equation. Ideal behavior, sorry. So, I hope it's clear for question number 13. Let us read question number 14. The vapor pressure of two liquids X and Y are 80 and 60 torr respectively. The total vapor pressure of the ideal solution obtained by mixing 3 moles of X and 2 moles of Y would be. So according to the information, you need to input the values of X, mole fraction of X, mole fraction of Y. Then finally you add the total pressure that would give you the answer for the question number 14. Now mole fraction of X, this is actually chi, Greek word. This is the mole of X plus mole of Y, right? So that's 3. According to the condition, see, you have X 3, Y 2. Okay, so 3 plus 2. So you have 3 by 5 for mole fraction of X. And for Y, okay, let us write mole fraction of Y would be NY and x plus, this is the total mole fraction in the solution. So it would be 2 by 5. 3 plus 2, it would be 2 by 5. So you have 3 by 5 and 2 by 5. What would be the total pressure in the system? Total pressure is the sum of the partial vapor pressure x plus Py, then you have mole fraction of y. So you have 3 by 5 as the mole fraction given to you. You have 80 as the vapor pressure of x, and the mole fraction is 2 by 5 into 60. So calculate and tell the answer. You have 48 plus 24, that is 72 torr. So in the question you have 72, right? So D is the answer to question number 14. I hope it's clear and understood. Question number 15, moving on to 15. Let us read. Iodine and sulfur dissolve in which of the following solvents? You have to apply the principle of like dissolves like. Carbon disulfide would be the answer for this question, because yes, iodine and sulfur would want to dissolve in the similar behavior or nature guided by the principle like dissolve like. Yes, let us read question number 16. If a 5% solution of sugarcane, you are given the molar mass 342, is isotonic with 1% of a solution of an unknown solute. The molar mass of unknown solute in gram per mole is. So for isotonic solution, you have the pressure equivalent. Okay, this is the isotonic condition. Pi 1 equals to pi 2. That means the concentration would be the same. Now, how do you write concentration? This is in fact mole per liter in terms of molarity. So now use this equation and find out the answer. 3 by 42, this is the mole. Mole means weight by molar mass. Okay, 342 is the molar mass of the sugarcane. We are given volume of yes, so it would be 0.1 because of 1 percentage, and 1 by molar mass. So you are required to find the molar mass of the unknown solid in gram per mole. So what would be the answer for this calculation? If you want to find m, you can easily cancel this 2. You have now 5 divided by 342, which is 1 by molar mass of the unknown. So m is equals to 342 divided by 5. So divide until the answer 68.4 grams per mole. Good. So the answer would be option B. It's evident, right? Okay, I hope it's crystal clear and understood. Moving on to question number 17. Let us read fast. Coolant used in car radiator is aqueous solution of ethylene glycol. In order to prevent the solution from freezing, this is from the theory part. See, in the cold countries like Russia or anywhere where there is ice, you cannot drive the car because the coolant water would freeze. Freezing point of water is 0 degrees Celsius. So you need to lower the freezing point as compared to the environmental freezing point. So what you have to do is you have to add a solute, non-volatile solute to water, because water is used as the coolant. So when you mix this ethylene glycol and water, the freezing point will drop to minus 36. Right, so this is a question based on cryoscopy. So you have to use the relationship delta TF lowering in the freezing point given to you is 0.3 degrees Celsius. So delta TF would be, in terms of freezing point, you have 0.3. Relate with the equation you have learned in your theory part of class 12. It is given, right? 1000 if it is converted to grams. This is actually the equation of molality and multiplied with your Kf value, WA. So you just input the values, you can get the answer WB into what here? What do you have to write here? 1000 divided by the molar mass of the ethylene glycol. You know the formula of ethylene glycol, right? It is ethane 1,2-diol. It's IUPAC name, and this is your ethylene glycol. Then you find the value of molar mass. It gives 62. This you need to know. Keep it in mind. Yes. So from this, you calculate the value of um, WB. Everything is given here. You simply transpose. You can cut this, cancel this, right? 5. Then multiply with this 10 point. It gives 31. 3 to the 6, 6 to the 18, 1.86. 1.86 and 1.86 gets cancelled. It's very simple, right? So the answer would be WB is, you're left with 50. 50 gram. Do you find the answer? Yes, it's there in option A. Good. So I hope it's clear and understood. Let's move on to question number 18. A solution of urea, molar mass of urea is 56. You know the formula of urea, right? NH2 C double bond O NH2. Molar mass is 56 gram per mole. Boils at 100.118 degrees Celsius. You know there's elevation in the boiling point of water because of the presence of this non-volatile solute urea. If Kf and Kb both are given, the above solution will freeze at what temperature? This is the question. Very important question. It's a nice question. Let us solve together. Now, delta Tf can be written as Kf into molality, and delta Tb can be written as Kb into molality. Hence, we have a new equation. Okay, molality in both the cases can be compared by this equation. Can I write like this? Yep. So delta Tf equals to delta Tb by Kb. This is the new equation. So from this, you do the arrangement, find out the unknown from the given values, Tb, Kf by Kb. Now what you need to do here is you have to find delta Tb, which you have to subtract from the given value, 100.18 minus 100. What is the elevation in the boiling point? 0.18 degrees Celsius. Now you have this value. Now you can easily find delta Tf can now be written as 0.18 into 1.86. This is multiplication, okay? Divided by given value of, yes, Kb 0.512. So after calculation, you would get approximately 0.654 degrees Celsius. So as the freezing point of water is 0 degree, you can say delta Tf is equals to 0 minus the lowering in the freezing point. So how much is given? Delta Tf is given. You have just calculated 654.654. 0 minus Tf. So this would be a negative term. So 654 minus. So the answer for question number 18 is B. I hope it's crystal clear and understood, right? Okay, moving on to question number 19. Let us read together. A solution is prepared by mixing 8.5 gram of dichloromethane and 11.95 gram of chloromethane in vapor pressure of dichloromethane. These are all liquid solvents, okay? Chloromethane at 298 Kelvin are 415 and 200 millimeter mercury respectively. The mole fraction of chloromethane in the vapor form is, you are given the molar mass of chlorine, 35.5 gram per mole. So which of the following would you find the correct answer? What you have to do is you have to find the molar mass of each and every one of them, find the moles, then you calculate the vapor pressure above the solution. That will give you the answer. So by applying the Raoult's law, pressure above the solution, let me write it in this way, can be written as the mole fraction of chloroform, the mole fraction of this dichloromethane respectively. So zero point 0.5, let me shorten it here. 0.5 is the mole fraction of chloroform given to you. You can easily find, okay, from these given values, weight by molar mass, that is your mole. Then further find out the mole fraction. That would give you the value of mole fraction of chloroform. And the vapor pressure of chloroform is 0.263. 0.263 plus 0.5 mole fraction into its vapor pressure, 0.546. Okay. So you are given in terms of millimeter mercury. You need to convert this to atmospheric pressure. Okay. 1 atmosphere equals to 760 millimeter mercury. So I have just converted this millimeter mercury into atmospheric pressure. So I'm writing these values here. From the given millimeter mercury pressure, you have to convert to the atmospheric pressure. Do the conversion. 1 atmosphere equals to 760 millimeter mercury. Then after this calculation of this will give you the value of the pressure above the solution, that is 4045. Now the mole fraction of the chloromethane in the vapor form, can I write it here? Yes. Chloroform in the vapor form, CHCl3 in the vapor form would be 0.1315, and this given vapor pressure, this is your Raoult's law. Okay, the answer for this question would be 0.325. So it's there in the option C. So the question is based on Raoult's law. I hope it's clear and understood. Okay, let us read question number 20. If alpha is the degree of dissociation of sodium sulfate, Van factor is I for the calculation of the molar mass would be. So sodium sulfate, when this dissociates, sodium sulfate gives how many particles? In totals, three particles. Okay, particles are ions. So before dissociation, this is having 1 mole, 0, 0. Now after dissociation, this would be 1 minus alpha, and this would be 2 alpha. Degree of dissociation is alpha, and this is 1 alpha. So I, let us count 1 minus alpha plus 2 alpha plus alpha equals 1 plus 2 alpha. The answer for this question will be 1 plus 2 alpha is the answer. Good. Let's read question number 21. This is simple, theory-based question. The molecular mass of solid cannot be calculated by which of the following? All are correct except option C. This is the wrong because yes, you cannot calculate by putting these values together. Okay, according to definition, delta TB is directly proportional to molality. You simplify from this equation, delta TB equals to Kb ebullioscopic constant into molality. Further find out by substituting, then you will automatically get all this answer except option C. I need not expand this. I hope it's clear. Okay, then moving on to question number 22. We have three aqueous solutions of sodium chloride labeled as A, B, and C with concentrations zero point 0.1 molar, zero point 0.01 molar, and 0.001 molar respectively. The value of Van factor for these solutions will be in what order? It would be in the order of C. The strength of the solution is keeping on decreasing as you go from A to C. Now the answer for this would be most likely, even if they are having different concentration, these are all the same solution and it gives two ions, so it would be A. Van factor would still remain the same because it depends upon the number of particles that you should know. The value of Henry's constant is 23, same thing, greater for gas with lower solubility. Easy. 24. Which of the following gas is the lowest value of Henry's law constant? It would be carbon dioxide because according to Henry's law, the mass of a gas dissolved per unit volume of solvent is directly proportional to the pressure of the gas at the constant temperature. That is mass is equal to Kp, that you know. That is, as the solubility increases, the value of Henry's law cannot constant decreases. And this carbon dioxide is more soluble in water among the given set of gases. This is the answer for question number 24. Moving on to question number 25. Let us see. A binary liquid solution is prepared by mixing N-heptane and ethanol. Which one of the following statement is correct regarding the behavior of the solution? I'm going fast. In case if you have any difficulty in knowing the question and answer, you can give it in the comment section. I will re-explain again. Now, let us move fast. Binary solution. Question number 25. For this solution, intermolecular interactions between the normal heptane and ethanol, they are going to be weaker. I'm talking about option B. It shows positive deviation from Raoult's law. Okay, because the solution of N-heptane and this ethanol, it is non-ideal. Non-ideal will not obey Raoult's law. So option B is the answer to question number 25. I hope it's understood. Okay, question number 26. Which one of the following salts will have the same value of Van factor I as that of the potassium ferrocyanide? You just find the number of particles that would give you the answer for this question. You can also write it down. Potassium ferrocyanide, right? So it generates 4 potassium ion and a ferrocyanide ion, FeCN6 4 minus, and aluminum sulfate Al2 SO4 3. When this dissociates, it gives aluminum 2 moles and sulfate. So see, in both the cases they give 5 particles. It's same. So question number 26 would be A. Potassium ferrocyanide will have the same value of Van Hoff factor. It's an easy question. I hope all of you can understand this question. Okay, moving on to question number 27. Relation between partial pressure and mole fraction is stated by which of the following law? So according to Raoult's law, the partial pressure of a volatile component of a solution is directly proportional to its mole fraction in the solution at any temperature. So P equals to P naught X, that is the pure state. So vapor pressure of component in pure form would be P naught X is the mole fraction of the component in the solution. 27 would be B, Raoult's law. I hope it's clear and understood, right? Good. Let's see question number 28, which is an application of Henry's law. So to increase the solubility of carbon dioxide in soft drinks and soda water, the bottle would be sealed at high pressure. So question number 28, likely the most closest answer would be option D. Great. Let's move on to question number 29. All right. I hope you're keeping up with me. For which of the following parameters of the structural isomers of ethanol and acetone would be expected to have the same values? You have to assume they are ideal behavior. That means they obey Raoult's law. So gases densities of ethanol and dimethyl ether would be the same at the same temperature and pressure, right? So what happens? The heat of the vaporization, the vapor pressure and the boiling point will differ due to the hydrogen bonding in the ethanol. You know, in ethanol you have this hydrogen bonding as opposed to that of the acetone. So gases densities at the same temperature and pressure would be the same. It is expected to be same because we are assuming ideal behavior and it obeys Raoult's law. I hope it's understood. Let's read question number 30. 5 gram of sodium sulfate was dissolved in X gram of water. The change in the freezing point was found to be 3.82 degrees centigrade. If the sodium sulfate is 81.5% ionized, the value of X, you're given the cryoscopic constant for water is 1.86 degrees centigrade Kelvin kg per mole. It is approximately, and molar mass of sulfur is 32 and that of sodium equals to 23 gram per mole. So how to answer this question? It is an experimental based type of question. So molarity from the formula you can easily decode delta TF by KF equals to 3.82. You're given the value of this lowering in the freezing point 1.86 is your cryoscopic constant. After calculation, you have this value 2.05 in 1000 gram of the solvent. So this is the experimental part. I shall write here experimental molarity. And since I don't have space, I write on the top the molarity which is theoretical. Let us write it somewhere here. Yes. Theoretically, we have from the formula, it is defined as the mole of the solid in weight of the solvent in grams, then you have to write here 1000 because it is usually expressed in terms of kilogram. So after inputting the values, you will get 5 gram 142 because this is the molar mass of sodium sulfate divided by the unknown weight. Okay, so multiply it again this with 1000 because you're expressing in terms of grams. Good. Now before and after you can calculate the moles by writing the equation. I shall write it here. Sodium sulfate When dissociated, it gives you two particles of sodium ion and one sulfate ion. So initially you have 1 mole, 0, 0. Then after dissociation, if let us consider X is the number of moles which undergoes dissociation, this must be X. So you can easily find out the Van Hoff factor from this. Okay, let me change the color to some else so that we can sharply distinguish. Right, I'll write in blue and red color. Okay, so Van Hoff factor, as you know, is the number of moles after dissociation with respect to initial mole before dissociation divided by 1. So what is the sodium sulfate ionized? 81.5%. That means it is 81.815, which is ionized. So put the value of this X in this equation and you can calculate. The given value of Van Hoff factor is 2.63. So after calculation and putting the value of X, you will get, okay, let us try and go slow here. Let me put 81.5 is 1 minus 0.815. This is the value of X. Because percentage, you need to divide by 100, okay? Plus 2 into 0.815 plus 815. Yes. From this, you solve the value of X, which turns out to be approximately 2.63. After having this value, you can come to the conclusion. This is the observed value 2.05, which we have calculated initially. Okay, this is the value of observed value divided by the total. The calculated value would be 0.0352 divided by X into 1000. I'm substituting here, okay, not to get confused. So I can be calculated from this formula and the answer would be approximately 45. Yes, 45 is the answer to question number 30. It's a little bit lengthy. Let us read question number 31. The vapor pressure of acetone at 20 degrees Celsius is 185 torr. When 1.2 gram of a non-volatile substance was dissolved in 100 gram of acetone at 20 degrees Celsius, its vapor pressure was 183 torr. The molar mass of the substance is. So you have to use the relation relative lowering of vapor pressure. So what was the relationship? We have learned P naught minus Ps divided by Ps equals W2 weight of the solute, M1 molar mass of the solvent, weight of the solvent, molar mass of the solute. Okay, so let us input the value. The pure state is 185 according to the question. It's given here, right? The vapor pressure 185 minus solution is 183 divided by 183. What is the weight? 1.2 and given molar mass is 58. 100 times the molar mass X. So calculate this and you get the answer. 64 would be the answer to question number 31. Let us read question number 32. In the mixture, A and B components show negative deviation S. So B, delta H mixing less than 0 is the answer to question number 32. Question number 33, which among the following will show maximum osmotic pressure? So Van Hoff factor is given, which is if you find out for ammonium phosphate, you have Van Hoff factor 4, 2, 3, and 3. So the highest goes for ammonium phosphate. This is the answer for question number 33, highest value of I. 34, yes, at 80 degrees Celsius, the vapor pressure of pure liquid A is 520 mercury and that of pure liquid is 1000 B. This is for B. If the mixture of solution A and B boils at 80 degrees centigrade and 1 atmosphere pressure, the amount of A in the mixture is. So 34, you can answer this from the Raoult's law of vapor pressure. So P1, or you can say P, let us write P total, the sum of P naught A. As usual, we have done this multiple times. So let me shorten it. P naught A is 520 for XA. XA is the mole fraction of A, P naught B, and XP. Okay. So 520 times that of the mole fraction of A, this would be 520 mole fraction of A plus the vapor pressure of B in pure state is 1000, 1 minus mole fraction of A. So what happens here? Total vapor pressure is given to you. It is 760 equals, you multiply this with the mole fraction XA plus 1000 minus 1000 A. So 480 mole fraction of A will be equals to 240. So can you find the mole fraction of A from this equation? Yes, divided by 480. This gives you a value of half, or 50%. Or you can say 50 mole percent. D is the answer to question number 34. I hope it's clear and understood. Let's read question number 35. The observed osmotic pressure for a zero point 0.1 molar solution of ferrous ammonium sulfate at 25 degrees Celsius is 10.8 atmosphere. The expected and experimental observed values of Vanna factor I will be respectively. So according to the question, the osmotic pressure, you know the relationship PV equals nRT, and you can find out the osmotic pressure pi. So question number 35 can be solved from this equation. Vanna factor I will be observed osmotic pressure divided by normal. Let me write here normal osmotic pressure. Okay. So from this equation, you have 10.8 as observed, and normal is 2.44. When you divide it, you get approximately 4.42. So what is the answer to this? E is the answer for this question. Easy. I hope it's clear. Let us read question number 36. The freezing point of equimolar aqueous solution will be highest for. So when you study, you have to go and analyze thoroughly, considering the worst case scenario. Don't expect and attempt easy questions. Learn to solve difficult ones so that you are well prepared and equipped for your upcoming NEET exam. So without, let us continue. We are left with only 8 questions. Let us read question number 36. The freezing point of equimolar aqueous solution will be the highest for. For this, you need to understand and keep in mind the value of freezing point. Glucose, which is a non-electrolyte, and the depression in the freezing point will be minimum. The value of I comes into play. Okay, so the one which cannot dissociate into ions are your carbohydrate, proteins, and fats, which are considered usually the biomolecules. The electrolytes, they usually dissociate into ions. So more the number of ions, more is the colligative property, be it lowering in the freezing point, elevation in boiling point, or the increase in the osmotic pressure, or relative lowering of the vapor pressure, which are ideal solution that obeys the Raoult's law. So always keep in mind the electrolytes, which gives maximum number of ions, will definitely give rise to more values of colligative property. So for this question, glucose, which is a non-electrolyte, the freezing point of equimolar solution will be the highest. So according to this question, glucose is a non-electrolyte, and hence the depression in the freezing point will be the minimum. Hence, freezing point will be the highest for this question, which is a monosaccharide, right? Okay, let me erase this part and let us read question number 37. If the solution boils at temperature T1 and the solvent at T2, the elevation in the boiling point is given. Very basic question. Subtract the value T1 minus T2 gives rise to the increase in the boiling point, where T1 is the boiling point of the solution and T2 is the boiling point of the solvent. Subtract it, you will get the answer. I hope it's clear and understood. Let's read question number 38. The freezing point of a 1 molar aqueous solution of Hydrofluoric acid is found to be minus 1.91 degrees centigrade. The freezing point constant of water is Kf 1.86 Kelvin kg per mole. The percentage dissociation of HF at this concentration is, the given options are 30%, 10%, 5.2%, and 2.7%. So how can you account for this? You can easily come to the calculation part. Let's write here delta TF. Mathematically, cryoscopy can be written as Kf into molality. And sometimes if it is electrolyte, always consider this I because it dissociates or associates. According to the equation, it is hydrogen fluoride, so it must undergo dissociation to some extent. Now delta TF divided by Kf into molality, the answer would be 1.91 divided by 1.86. 1 molar solution would be 1. So calculate approximately, you get 1.02. This is the Van Hoff factor I. For the dissociation part, I'll write at the bottom, hydrogen iodide dissociates liberally as such. Okay. Now for this, if I consider alpha is the degree of dissociation, this would be alpha and alpha. So the total mole after dissociation would be equals to, this is your I. Why I'm not writing 1? Because initially you have taken 1 as the number of moles before the reaction starts. So I equals to, after calculation, you have 1 plus alpha, which would be equals to, this is the value of I. Calculate. You can easily answer this question. You now have 1.027. So 1 plus alpha is 1.02, let us say. So alpha would be 1.02 minus 1. This is 0.02. So this is, when you multiply with 100, the most closest answer would be option D. So I hope this question is clear and understood. Moving on to the next question, 39. A solution containing 0.85 gram of zinc chloride in 125 gram of water freeze at minus 0.23 degrees Celsius. The apparent degree of dissociation of the salt is, which of the following is the correct answer? You need to find the molar weight for this relationship. Okay, molecular weight would be, let us write down from the cryoscopic equation, Kf into weight into 1000 divide by delta Tf into its weight. Okay, so when you substitute the values here, 1.86 into 0.85 multiplied 1000 divide by 0.23 into 125. Okay, so approximately you have 55 grams. So from this, you can easily answer I, it is the total number of moles normal by observed 136.3 divided by 55, which would give rise to 2.47. 2.47. So when this zinc chloride ionizes, it gives zinc ion and chloride ion. Zinc ion and chloride ion. So Van Hoff factor for this would be I equals to 1 minus alpha plus alpha plus 2 alpha divided by 1, right? So we initially got this as 2.47. So what is the value of alpha now? Subtract from this 1 minus alpha, you would get alpha as 0.735. Multiply with 100, you get 73.5. So approximately 73 would do. The answer for question 39 would be C. I hope it's clear and understood, right? Okay, moving on to the next question. Question number 40. During depression of freezing point in a solution, the following are not in equilibrium, which is a liquid solvent and the solid solvent are in equilibrium. So option A is the answer for question number 40. It's clear, I hope. Let's move on to question 41. The molecular weight of benzoic acid in benzene as determined by depression in freezing point method corresponds to. See, benzoic acid forms dimer, such as in the acetic acid. Okay, for acetic acid, dimerization is readily taking place because this hydrogen, which is electropositive, would want to combine readily. Okay, let me erase this. Just for explanation, I'm drawing the molecular structure of acetic acid. CH3. So suppose this is whenever there's a functional group carboxylic acid, there is a tendency to undergo dimerization, which means association, which decreases the particles, number of particles. So benzoic acid forms dimer in case of benzene. Same thing can be analyzed for benzoic acid. You can try this, okay? And this would undergo dimerization. So 41 would be B. Option B is the answer for question number 41. I hope it's understood. Let's read question number 42. How many grams of methyl alcohol should be added to 10-liter tank of water to prevent the freezing at 268 Kelvin? You are given cryoscopic constant 1.86 Kelvin kg per mole. So use the equation according to cryoscopy. You have learned that delta TF is equals to freezing point, okay, KF multiplied with the molality. Now this lowering in the freezing point you can subtract from the freezing point of water, which is 273 or 0 degrees Celsius. 268 equals to 1.86. What is the molality? By definition, weight per mole of the, okay, let's write WBMB is considered as the solid per weight of the solvent in kg. So after subtracting, you have 5, 1.86 into weight. Now you have 32 because 32 is the weight of molar weight of methanol. And how many gram of this liter? 10. Okay, so after calculation, the weight would give rise to approximately 860.2. Okay, so 860.2, which is approximately the closest answer would be C. C is the answer for question number 42. I hope it's understood. Let's read question number 43. The solubility of nitrogen. You have to apply this, the Henry's law. By mere looking, you can easily answer the question. So calculation would be pressure is directly proportional to its mole fraction. So from this, pressure equals to Henry's constant and X. Solve this. Answer would be D. Question number 44. Let's read. When mercuric iodide is added to the aqueous solution of potassium iodide, then the freezing point is raised. Now, as usual, the last question is left for you to answer. Solve the question and try to answer. Give the answer in the comment section. And thank you for keeping up to the end. Happy learning. See you in the next episode.